Okay, now I'm going to cover questions 4.1. This was a multiple choice question from a previous midterm, 4.1.1 and 4.1.2. 4.1.1 is sort of intuitive, but 4.1.2 kind of maybe does your head backwards, and I will try to give a good explanation. Okay, suppose an individual has a U-shaped indifference curve. Okay, now these axes will represent two goods. Okay, what's the good we're talking about being willing to give up? Steak. We'll call this S, and this W, wine. Okay, I say U-shaped indifference curves. What I meant by that, and it says here, is with a diminishing marginal rate of substitution everywhere. Okay, so that looks like the thing we see most. So her indifference curves, looking like this. The slope's getting shallower and shallower everywhere. The amount of steak she's willing to give up to get a unit of wine decreases as the amount of wine she has increases. Okay, and I say it specifically. I talk about her current consumption. The question asks, assume her optimal consumption involves buying a positive amount of both goods. Okay, so I'm not worrying about the so-called corner solutions that we talked about, that chia pet example in the lecture. Okay, so her optimization is somewhere in the middle. Okay, at her current consumption plan, or there's a point we're considering, this may not be optimal, we're deciding, is this optimal? At her current consumption plan, her marginal rate of wine for steak is 1/2. And just so we understand what I mean, well, here it would be the same, but just so we understand what I mean, it wouldn't be the same. Okay, so just so I understand what we mean, at her current consumption plan, whatever she's choosing to consume, she's willing to give up 1 unit of steak only if she was to get 2 extra units of wine at the margin. 2 to 1. That's the slope here. That's her marginal rate of substitution exactly at that point. And of course, this is an approximation. Okay, suppose also that the price of steak is 2 pounds per ounce and wine 1 pound per ounce. Okay, so let's think about the slope of this budget line. So here we have marginal rate of substitution equals 1/2, right? Because we take the absolute value. The slope's negative 1/2. And they're saying, what is the price ratio? Or what is the slope of the budget constraint at this point? Okay, she can afford this. And steak is twice as expensive as wine. Okay, so if she gives up 1 unit of steak, on the budget constraint, she's able to get 2 units of wine. Okay, another way of thinking, so the slope is 1 to 2, just like the slope here of the marginal rate of the indifference curve, just like the marginal rate of substitution. So how much, if she only purchased steak, how much should she purchase? Well, whatever her income is, divided by 2 per ounce. If she only purchased wine, what could she get? Well, her income divided by 1, or just her income. Okay, so here we see that this should be half as high as this. Okay, it's not quite to scale. Okay, but we still see this is twice as long as this, so it's a 2 to 1 slope. Okay, so here we have the marginal rate of substitution equals 1/2, which is also equal to the price ratio. It's equal to the price of steak. It's equal to the price of wine divided by the price of steak. Okay, because the price of steak is twice the price of wine. Okay, just to be sure. So it looks like at this point she actually is optimizing. So the question says, continue with her current consumption, buy more steak and less wine, buy more wine and less steak. Not enough information to answer the question. Well, looks like the answer is in fact A. Okay. And we could also do this thinking about bang for the buck. Okay, so her marginal, what amount is she willing to give up? She's willing to give up 1 steak to gain 2 ounces of wine. Okay, this means steak must be more valuable than wine. At this point, steak yields twice the marginal utility as does wine. So we know that the marginal utility of steak at this point is equal to twice the marginal utility of wine at this point. Okay, and the price of steak is also equal to twice the price of wine at this point. Correct. Okay, because the price of steak is 1, the price of wine is 2. So if I look at the bang for the buck here, I have, let's divide this by this. Well, let's rearrange it. So marginal utility of steak is twice the marginal utility of wine. Marginal utility of steak divided by the price of steak is equal to, well, these are equal and these are equal, so it can just divide this by this. 2 marginal utility of wine, 2 price of wine. So here we get marginal utility of steak over the price of steak equals the 2 disappears, marginal utility of wine divided by the price of wine. Okay, now I will address the slightly more difficult question. It says, which is the steak and beer question, where these things are, the one gives you more marginal utility per unit, but the other is cheaper per unit, okay? So it's one may outweigh the other. Okay, so now 412, it says, suppose an individual's marginal rate of substitution of steak for beer is 2, and she is consuming some of both goods. Okay. So here we have, let's put beer on this axis. No, okay. I'm going to put beer on this axis because it's easier for me to remember in terms of the thing we're willing to give up. Okay, so let's put beer over here. And I'll now put steak on this axis. Okay. At the current consumption choices, she is willing to give up, wherever she's chosen, she's willing to give up 2 beers to gain an extra steak. 1, 2 to gain 1. So her indifference curve should, at the point she's choosing, should have this 2 to 1 slope. Okay, this is a little bit difficult to draw because we have very extreme slopes, so I may not draw it completely to scale. Okay, these axes may not be exactly the same, okay? So at the point she's choosing, the indifference curve should have this 2 to 1 slope, okay? So maybe her indifference curve looks like this. Remember, it should never slope up, but we're also assuming, I believe the question said, well, let's imagine the question had said, okay, that's right. So this would be if there was diminishing marginal rate of substitution. Actually, the question didn't state that there was diminishing marginal rate of substitution. Okay, okay, but she was willing to give up 2 of these to get 1 of these. Okay, so there is some willing to give up 1 to get the other. So we know we don't have, what's this? Perfect complements, because then there's no willing to give up 1 to get the other. At least not at those vertices, not in a general sense. Okay, let's just ignore that for now. Okay, but what else could it be? Well, it also could be perfect substitutes. We could also have flat indifference curves, and that's going to would yield us in this case the same answer. Okay, but for now, let's imagine she has these convex indifference curves, diminishing marginal rate of substitution indifference curves, where the slope's getting shallower everywhere. At the point she's consuming, that slope is -2. Okay, what about the price ratio? Well, the price ratio, so this is 2 to 1. The price ratio, steak is 1 and beer is 1/4. Okay, so we can ask how much beer, when we were looking at the slopes, how much beer does she have to give up to get 1 steak, right? So I could say price of beer times beer plus price of steak times steak is equal to her income, and then rearrange this to see how does beer change as we change the amount of steak. We get PBB equals I minus PS S, or the amount of beer she can obtain is equal to income over the price of beer. If she buys only beer, this is how much beer she gets, minus PS over PB times the price of steak. So as she consumes more steak, she gets less beer at this rate. At what rate? Well, we said the price of steak is 1, price of beer is 1/4. So beer equals income divided by 4 minus, divided by 1/4 income divided by 1/4, minus 1 divided by 1/4. In other words, she gets 4 beers, times steak, forgot the steak there. She gets 4 beers minus 4 times however many steaks she chooses. For every steak she buys, she has to give up 4 beers. So the slope, she has to give up 4 beers to get 1 steak. The slope is -4 of the actual budget constraint. So at this point, the slope will be steeper, or at this point and at every point. Okay, I haven't given myself enough room to hit that axis, but the actual slope of the budget constraint is 4 to 1. So she's willing to give up 2 beers to get a steak, but she would have to give up 4 beers to get a steak. Okay, so she wouldn't certainly want to give up beers to get steak. Okay, so the question, buy more steak and less beer, buy more beer and less steak. She wouldn't want to buy more steak and less beer. That's too much of a sacrifice. Does she want to continue with the current plans? Well, we don't seem to have the same slopes, right? The marginal rate of substitution here, it's going to equal, the amount of beer she's willing to give up, to get a unit of steak, is greater the more valuable steak is, and smaller the more valuable beer is. Margin utility of steak over beer, well, we said this is equal to 2. Okay. Well, that's the slope, so I've already done it. Okay. So, this isn't her optimal point. She doesn't want to give up beer to gain steak. This is our steak. Does she want to give up steak to gain beer? Well, graphically, it would seem like it, okay? It would seem like she can find there should be an indifference curve that lies above this at a point with less steak and more beer, okay? We see, so if she has to give up 4 steaks to get 4 beers to get 1 steak, that means if she gives up 1 steak, she could gain 4 beers, okay? She could gain 4 beers, but if she were to give up 1 steak, how many beers would she need to get to make her equally happy? Well, she's willing to give up 2 beers to get 1 steak. That means she's willing to give up 1 steak to get 2 beers. So if she gives up, what did I just say? If she gives up 1 steak, she's willing to give up 1 steak to get 2 beers, but if she gives up 1 steak, she can actually get 4 beers, which would make her better off, okay? So she should move towards buying less steak and more beer. Answer C, buy more beer and less steak, okay? If we have these convex indifference curve, these diminishing marginal return indifference curves, at some point, and if we have, let's say, as she adjusts towards more beer and less steak, at some point on the budget constraint, as she gets more beer and less steak, she'll be less willing to give up steak to gain beer, okay? She'll have to give up, she'd have to give up more beers to get, she's less willing to give up steak to gain more beers, okay? Because she has less steak and more beers, she'd need even more beers to be willing to give up 1 steak. And at some point, this will have then the slope of -4 that equals the budget constraint, okay? On the other hand, it's also, nothing I said in this question rules out that these 2 goods could be perfect substitutes at rate, what did we just say, 4 to 1? So it could be that this is what her indifference curves look like. Sorry, not 4 to 1, 2 to 1. 4 to 1 was the price ratio. So it could be that this was what her indifference curves look like. And then, but still, at this point, we said that she's willing to give up 1 steak to get 2 beers. Right? She's willing to give up 2 beers to get 1 steak, or 1 steak to get 2 beers. But if she gives up a steak, since steak is 4 times more expensive, she can actually get 4 beers. which makes her better off, right? But in this case, she won't stop there because we don't have this diminishing or in this case increasing marginal rate of substitution. The marginal rate of substitution will remain 2 to 1. So she keeps being willing to make this trade-off until she reaches the point where she's only consuming steak, only consuming beer, and no steak. Okay, but that yields the same answer to this question. Still, at this point, she should buy more beer and less steak. She hasn't chosen the correct or the optimizing bundle of beer and steak. And it's explained a few different ways in the handout as well. We can think about she gets greater, at this point she's getting greater bang for the buck from beer rather than steak, etc.